In this video, I'm going to demonstrate how to summarize quantitative data. And here we have a variable called submarine sandwich length. And the sub-sandwiches are measured in inches. Because we're talking about footlong sandwiches, we want the sandwich to be, on average, 12 inches. And so what we have here is a random sample. The first sandwich is 11.863 inches long. The next sandwich is 12.113 inches long, etc., etc. So the first thing we have to do is we're going to copy the data into Excel. So I'm going to open up Excel and copy it right here. And then the next thing I want to do is I'm going to copy these lower and upper limits down here, because we're going to create a frequency table. Open up Excel. We'll paste that right here. So we have the upper limits and the lower limits of the data for each interval. Okay. And I think the first thing I'm going to do is I'm going to calculate the max and the minimum. So the minimum is found by typing equal min. I'm going to go up here and highlight all the data. I'm going to close the parenthesis, and I'm going to copy this part of it to make it quicker. Copy. So the minimum is 11.715. So the minimum is in this interval. Now I'm going to calculate the maximum. Typing equal max. I'm going to hit Control V for pasting. And then the maximum is going to be 12.317. And notice that the maximum is in this interval. So the minimum is in this interval. The maximum is in this interval. How do I get all of the sandwiches up here that are in this interval? Well, I'm going to type frequency here, or freak. And then I'm going to highlight. I'm going to hold down the shift button, use the arrow key down, and I'm going to type equal frequency. Equal frequency. And then I'm going to highlight the data up here. And then I'm going to F4 it. Yeah, I don't really need to do that. So I'll hit comma. And then I'm going to click the bins array right here. Y'all see that? So I highlight the data up here in the blue box. And then I highlight the upper limits in the red box. Close the parenthesis. And then if I hold down Control Shift and enter, I get the frequencies. Oh, I need to go back and look at the minimum again. The minimum in this case, in most cases, in this particular problem, the minimum will be in this interval, but it is slightly bigger than that value, which is why there's a 0 here. So your eyes can play tricks on you. But notice the maximum is in that interval, and this refers to the maximum. So the minimum is one of these 5. Okay. And then I'm going to move this over to the side a little bit. Bring up my frequency table. I also want the cumulative frequencies. So a real quick way to get the cumulative frequencies is to do this. I'm going to type sum. I'm going to highlight the data over here. And then I'm going to freeze C12. And this is kind of a real quick trick. I'm going to freeze C12. So when I hit F4, I'm leaving C19 free, but I'm freezing C12. And I'm going to show you why in a second. So when I grab the bottom right-hand corner and I push it up 1, what happened? Freezing that first cell, anchoring that first cell right here at C12, and not doing the same thing for here, allows this box to get skinnier. And these are what we call the cumulative frequencies. And I just continue to do that. And you can see why freezing that is important and why not freezing that cell is important. So 0, this is 0 because that's 0. This is 5 because 5 plus 0 is 5. This is 11 because 0 plus 5 plus 6 is 11, etc., etc. So these are my cumulative frequencies. And I'll kind of push this back over here a little bit. And I'll type them in. So, whoop. So we got 0, tab, 0, 5, 5, 6, 11, 26, 37, 9, 46, 10, 56, 3, 59, 1, and 60. Now, if I hit enter in my open math, the way I've set up the settings is you can do this several times. It looks like we got all those frequencies and cumulative frequencies correct. Now I need to calculate the mean, the standard error, yada, 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 all the way down the count. So I'm going to go back to my spreadsheet here. Notice I already calculated or copied in these things from my open math. Okay, to calculate the mean, what I'm going to do is I'm going to type equal average. I got to go up here and get the data again. I'm going to copy A1 to H8. I'm going to hit enter. I'm going to type, I'll come back to standard error. I'm going to type the median, and then I'm going to paste in A1 to H8. I'm going to type mode, and then paste in A1 to A8. I'm going to type in the standard deviation command, stdev.s. We use .s because it's a sample data. We don't have the population. And then I'm going to type A1 to A8. I'm going to do the population of the sample variance, the variance.s, that's the sample variance, and then A1 to A8, H8. Then to get the kurtosis, I'm going to type equal KURT. And this, when Excel calculates kurtosis, it's actually calculating excess kurtosis. And we'll get back to that in a second. And then A1 to H8. And we're going to type skew for the skewness, A1 to H8. The range is simply the maximum minus the minimum, and then the sum, and then the count. So we have 60 observations, which we already know that from the cumulative frequency here. We also forgot to type the total here. We want to sum the frequencies, and we get 60. Now the standard error, the way I calculate the standard error is I just type square root, SQRT. Then I go down to the sample variance, and I divide the sample variance by the count. That's how I calculate the standard error. Okay, now we can fill these in one at a time, right? So put that right there. And then the mean is 11.998. Standard error is 0.017. The median is 11.999. It's really close to the average. The mode and the median are the same thing, and both of those are really close to the average. The standard deviation is 0.130. The sample variance is 0.017. The kurtosis is 0.053. Skewness is 0.177. The range is 0.602. The minimum is 11.715. Maximum is 12.317. The sum is 719.903. If you divide that by the count, you get the average of 11.998. I'm going to go ahead and hit enter because I think there's a mistake. You might have noticed that I paused a long time back there. Okay, no mistakes. It's odd that the standard error and the variance are equal. That implies I might need to go buy a lottery ticket because that usually doesn't happen. That's why I paused back there. But hey, numerically, weird things happen. Now I want to demonstrate that the 50th percentile is the same as the median. So what I'm going to do is I'm going to just go ahead and copy this command into Excel. And I'm going to say the median is the same thing as the 50th percentile. So to calculate the 50th percentile, we need to highlight the data again. And we're going to type a comma, and then we need a 0.5. That's the 50th percentile right there. You hit enter and you get 11.99. Okay, we're going to do the second quartile now. I'll go ahead and copy this right here. And I'm going to demonstrate that the second quartile is the 50th percentile, which is the median. So I highlight the data up there. I hit a comma, and then I'm going to type, notice it says median value, 50th percentile. So we're going to hit 2 there, the second quartile. And we get 11.999. For the second quartile, the 50th percentile, and the median are all the same thing. They're always the same thing. I'll hit enter to see what it looks like. And we're doing really good. Okay. Now, just for your own information, if I were to type in here the 25th or type in 0.25, this gives me the 25th percentile, which is lower, 11.914. If I change this to 75 or 0.75, I get the 70th percentile. Okay, so the top 25 starts at 12.09225 inches. If I change this to 0.90, I get the 9th percentile, which differentiates the top 10% from the bottom 90%. I'll go ahead and change it back to 0.5. The first quartile is the 25th percentile. The third quartile is the 75th percentile. Let's just verify that. If I change this to 7, these two things are the same thing. If I change this thing back to 2.5, and I change this to 1 right here, I get the first quartile equaling the 25th percentile. Okay, what do we need now? We need to calculate the z-score of a foot-long sandwich that is 11.755 inches long. So I'm just going to go ahead and copy this right here. I'm going to copy this, and then I'll go ahead and paste it right here. Okay, now I want to. So this is an observation, and I want the z-score of that observation. Where is it at up here? 7.555. Right here. So it looks like it's the 8th, 16th, 18th observation. We want the z-score for the 18th observation, 11.755. The way to calculate the z-score is we type equal parentheses, and we take the 18th observation, 11.755, and we subtract off the mean, and we divide by, so that right there is called the deviation in the mean. We're going to divide the deviation in the mean by the standard deviation, which is 0.130. And so 11.755 has a z-score of negative 1.88, which means 11.755 is not only below the mean because the z-score is negative, it's 1.88 standard deviations below the mean. That's what the z-score means. So I'm going to copy it, and I'll paste it right here. We only need 3 decimal places, so we got a 6 next to a 4, so the 6 stays equal to 6. And what the z-score means or implies is that this observation is 1.876 standard deviations below the mean. You have to choose above, below, or equal to. Okay. Now we want to calculate what percent of footlongs are within 1 standard deviation of the mean. So what we're going to do, the way we're going to do this is going to be really kind of cool. What we're going to do is I'm going to go ahead and freeze the mean and the standard deviation. Then I'm going to copy this up here. I'm going to copy this equation up here. I'm going to put all the z-scores. This is going to calculate the first z-score. And if I drag this across, I get the next z-score. So I'm going to put all the z-scores over here. Okay. And then what I'll do is I'll pull this down to here. Now I need to delete these here, right? Because there's nothing in that cell. So I need to delete whatever's in these cells here. Okay, so these are the z-scores that correspond to these observations. Okay, and the next thing I'm going to do is I'm going to type number of standard deviations. I'm going to type 1, 2, and 3. Okay, so the first thing I'm going to do is I'm going to type equal frequency. I'm going to highlight the z-scores up here. I'm going to highlight the z-scores up here. And then I'm going to type comma and just click on the 1 there. Actually, I'm going to do my minus sign right there. Okay. And what this does is it gives me, it looks in this blue box up here, and it looks for all the values that are less than -1. And here's an example that is less than -1. Negative 1.04 is less than -1. I got a negative here, right? So this right here is -1. And this is looking for all the values up here in this blue box that are less than -1. So there's 1, 2, 3, for example, right? And how many are less than -1? 9. So the next thing I'm going to do is I'm going to just pull that over here. I got to drag this box back to here. I'm going to drag this box back to here. In fact, what I'm going to do is I'm going to F4 J1 to Q8. Then I'm going to get rid of the negative sign. So now what this is doing, it's looking in this blue box, and it's trying to find or count all the observations that are less than 1. I got rid of the negative sign, so this is just equal to 1. How many of these are less than 1? 51. Now, before I pull this down, I got to F4 this. Now, when I drag this down, there's only one observation up here that is less than -2. Remember, this is -2 now, right? Because I got a minus, and that's 2 there. So there's only one of these that is less than -2. And none of these up here are less than -3. Again, because it's -3. Now, if I click on this cell, what is this doing? It's counting all the observations up here, all the z values that are less than 2, and there happen to be 58. And this is looking at this blue box, and it's counting all those that are less than 3. Now, if I take this difference, I get 42, 57, and 60. These are frequencies. I want the percent of z-scores within X standard deviations of the mean. Okay, so what I'm going to do is I'm going to take this and I'm going to divide it by 60. And I'm going to multiply by 100. So this is a percent. So 70% of these observations are, 70% of these z-scores are within 1 standard deviation of the mean. 95% of them are within 2 standard deviations of the mean. And then all of them are within 3 standard deviations of the mean. Now, these z-scores are the z-scores of these observations. So what this means is, if 70% of the z-scores are within 1 standard deviation of the mean, now why do I say 1 standard deviation of the mean? The standard deviation, the mean of z-scores, is 0. The standard deviation of z-scores is 1. That's why we call it standardizing. We're standardizing these observations by taking the difference between the observations, the mean, and then dividing that deviation, the mean, by the standard deviation. That's called standardizing. This right here is a standardized version of the observations. And because we subtract off the mean from the first observation here, inches minus inches, the numerator is in inches, but the standard deviation is in inches. So we got inches divided by inches, which is unitless. So all of these z values are unitless. These observations are all in terms of inches. These are all in terms of nothing. Or you could say the units are standard deviations. So the units over here are inches, and the units over here you could say are standard deviations. And this is called standardizing the variable, which is why the mean is 0 and the standard deviation is 1. So if 70% of our z-scores are within 1 standard deviation, 70% of our observations are within 1 standard deviation. If 95% of the z-scores are within 2 standard deviations, then 95% of these observations are within 2 standard deviations. If 100% of the z-values are within 3 standard deviations, then 100% of the observations are within 3 standard deviations. So let's go and fill in this information. Let me drag this over here so I can see it. So there are 70% footlongs within 1 standard deviation of the mean. There are 95% of footlongs within 2 standard deviations of the mean. And there are 100% footlongs within 3 standard deviations of the mean. Now, if you remember the empirical rule, the empirical rule talks about what percent of the observations of a normally distributed variable are within 1 standard deviation of the mean. Now, if you don't remember, you can click on this link right here. And this is kind of cool. I like this calculator here. I'm going to click on between here. And I'm going to type in 1. And this is the normal distribution here. Whoops, I got to type -1 here. This is the standard normal distribution, mean 0, standard deviation of 1. I typed in -1 and 1, and it gives me 68.27. I'll go ahead and copy the 4 digits there. Go back to my open math. I'm going to type in 68.27, or to 1 decimal place, 68.3. Okay. So according to the empirical rule, a normally distributed variable, 68.3% of observations of a normally distributed variable are going to be within 1 standard deviation of the mean. Now let's go over to the calculator again and change it to -2 and 2. and we get 95.45. So I'll just copy these 4 here, paste them into Excel. I'll change this to 95.5. And then we want to do the same thing for within 3 standard deviations. So we'll do -3 and 3. And we get 99.73. So let's copy this. Paste it right here. 2 decimal places, 99.73. 99.7% of observations of a normally distributed variable are within 3 standard deviations of the mean. Okay. Now I'm going to let you figure out what the skew should be and the excess kurtosis. For our data, the kurtosis was 0.053 and the skewness was 0.177. But the data may not be normally distributed. It kind of looks like it is, right? Because 70 is pretty close to 68.3, 95 is pretty close to 95.5, and 100 is pretty close to 99.7. So based on these 3 numbers here, this is from our data itself, and this is from a normal distribution. These numbers are pretty close to those numbers, so we might have a normal distribution. So I'll let you figure out what the skew is of a normal distribution and the excess kurtosis, and then you can compare it to what our data has in terms of skew and kurtosis. Now, one thing before I go in this video is I want to create a histogram of our observations. So the way you can do that is you can highlight the data, you can go to Insert, and then you click on Recommended Charts, and you can choose Histogram. Okay, we got a bit of an issue here. Let me back out of here. What we're going to have to do is we're going to have to stack this data. Excel doesn't like it like that. So what I'll do is I'll just stack it real quick. Stack it in one column. Normally, I always have my observations stacked in one column. But for this stuff, I just left it as it was in my open math. So now let's go cancel that. Now I'm going to go ahead and highlight the data here, and I'll go to Insert, Recommend a Chart. I'll click on All Charts, and I'll click on Histogram. So that is the histogram for sandwich length, and it does kind of look like it has a normal distribution. It kind of goes up and then it comes down.